Okay, class, this wraps up day one. I hope you guys had an amazing first day at Laurie Engineering. Our next class will be after your third reading week. So hope you guys have an amazing day.
Yo, Hashim?
Nimesh, bro, I haven't seen you since high school.
Yeah, how you been, bro?
I've been doing really well. Where do you go, by the way?
I go to Wadss for engineering.
Oh, cool. I just finished my first class at Laurie Engineering.
Wait, you didn't get into Wadds engineering? I swear you had better grades than me in high school.
I didn't get in. Dude, I don't even know how the process works.
Yeah, like how does the admission process even work?
I was talking to a lot of my friends, and I feel like there's a lack of standardized process amongst Ontario universities.
Only if there was
a way.
Introducing Wadds!
Waterloo Admission Decision Support System.
Waterloo Admission Decision Support System, a DSS made by Wadss, Hashim, and Nimesh. So here's some of our personal thoughts on admissions in general. So university admissions is something that affects you for the rest of your life. What program you go into, which school you choose, that has a great impact on your career, your finances. And a lot of us believe that there have been certain flaws or discrepancies in the system or the ways that universities look at their applicants or admit their applicants. We all personally believe that criteria such as where you're from, what high school you went to, quotas from certain provinces, gender, sexual orientation should not matter to universities. I personally know some people who have had higher averages than their counterparts from other provinces, but maybe due to a quota system, the person from the other province got in. Or scenarios such as someone having like a 97% average with minimal extracurriculars not getting in versus someone with a 90% average and having decent extracurriculars. So there's definitely some sort of maybe a misunderstanding between in society or among students. So our motivation behind this project was definitely to understand the admission process as a whole and definitely come up with a tool that can maybe help admissions officers view applicants and view students in a better way, or for students to get a greater understanding of the admissions process and what they can do to get into the school or program that they want to get into.
The business problem addressed in the project is the lack of a standardized system in Canada when assessing university applications. So many countries around the world have a standardized exam that all students across the country must write in order to get admission to a post-secondary institution. For example, in USA, all the students are required to write their SATs in order to apply to a post-secondary institution. In Canada, there is no standardized exam to assist the institutions in the assessment of university applications. So post-secondary institutions currently receive subject grades from the applicants' high schools, but there's a lot of variables to consider. Each high school can have different grading systems where it may be easier to score higher marks in one high school than the other. Here's where the biggest problem lies when comparing standardized exam system with the variable grade system in Canada. More variables in the Canadian university application system include supplementary applications, video interviews, and extracurriculars. So overall, to pinpoint the main business problem addressed in this project is that there are many variable factors in the post-secondary application system in Canada, and there is no standardized system to assist Canadian post-secondary institutions to see which candidates that have applied are the best out of the options. Overall, our decision support system is to help provide each student with a fair and equal opportunity, and it should disregard any external factors such as sex, race, ethnicity, or religion. So to explain the current admissions process at University of Waterloo for engineering, currently the students have to submit their grade average, an AIF, which is like a supplementary application form, their extracurriculars in school and out of school, and also conduct a video interview, which is optional. So to understand more about the UW engineering admissions process, we were able to interview members from the UW admission team.
So thank you to Nimesh for explaining the current admissions process at Waterloo. Now I'm going to give you a demo of our entire DSS. So let's assume that I am an admissions officer at the University of Waterloo. Now when I open up the tool, I will find three buttons on my right and various columns, which are just the different factors and criteria that we admissions officers use when admitting students into the University of Waterloo. So as an officer, I have hundreds and hundreds of applicants' data. That is the grade average, the IF, extracurriculars, and video interview. So the system is very easy to use. All I have to do is just copy and paste whichever rows of data I need help with making a decision for. Copy that and go back into this sheet and just Control V, paste them over here. And then I'm going to click a button called Find Probability. So this button gave me all of the probabilities of acceptance for this for each student. Now, however, because the data is not sorted in any ways, I can sort the applicants from highest probability to lowest probability. Now, once that's done, I'm allowed to place a threshold, and this is just the sort of the minimum probability of students that we want to accept, and the software, the program will give me will color code everything above that threshold and everything below the threshold. So if I do 0.65, as you can see, everything above 0.65 is highlighted green, everything below is highlighted red, and this can greatly help admissions officers to make a better informed decision.
Thank you so much, Hashim, for the demo. I just want to take some time to explain a little bit about the data that we used inside the model. So we were working with a total of 400 data points, and as you can see here, we have the first 5 rows of our data. You can see the columns. Firstly, we have result, which is the binary variable, yes or no, or in this case, admitted or not admitted. And then we have grade average, AIF, which is scored out of 5, in-school extracurriculars and out-of-school extracurriculars, which are out of 3, and then you have the video interview, which is also out of 3. We split the result column with a 50-50 split for a more balanced and accurate model. As we know, the best machine learning models are the ones where the data vectors are as close to each other as possible. So some ways you can get them as close as possible is using either cosine similarity or the distance between the vectors. So here's an example of the 50-50 split. So as you can see on the x-axis we have 0 and 1. So 0 being not admitted and 1 being admitted. And we can see that there's a split, 50-50 split, so 200 students were accepted and 200 were rejected. Here's a graph of the breakdown of the grade average. So as, again, you can see in the x-axis the 0 and the 1 and the different grade averages that the students had and the count of the grade averages. Moving on, so here we have 2 graphs. Firstly, we have the breakdown of admissions by video interview score. So the students that chose to do an interview and the students that didn't choose to do an interview, and the grade that they got on the video interview. And then on the right side we have another graph which is breakdown of admissions by grade. So we can see the frequency of the grades that each student got. So as we can see here that the range is 95 to 100. So around 70 students got between 95 to 100. So moving on, the next slide is a bit more about our machine learning model. We chose to incorporate logistic regression. So before I kind of explain how we're using logistic regression, I just want to explain what really logistic regression is. So logistic regression is a statistical method used for analyzing a data set in which there are one or more independent variables that determine an output or an outcome. The outcome has only 2 binary possibilities. So it can be yes or no, or true or false, or in our case, admitted or not admitted. So over here we have the logit function right over here, and we can see these coefficients. Later on, we will see how and where we are obtaining these coefficient values from. Another big part of logistic regression model is the sigmoid function, which basically allows the y values to fall between 0 and 1. And on the next slide, we can see a clear depiction of the function. So as you can see, the y values are between 0 and 1, and over on the right side, we have the sigmoid function.
We were able to train the logistic regression model using Python, and this was a form of supervised learning. To be more specific, the Python libraries used for this was scikit-learn for machine learning and pandas in order to import the CSV files. We were able to use two different variances of train test split models, 70-30 and 80-20. The reason we did this is we want to see which one obtains a higher accuracy. The 70-30 split had a higher accuracy, hence the optimal b-values was obtained from that train test model. The optimal b-values was then transferred to Excel. And the b-values are unique for each program. This is an important concept to understand because our setup for the logistic regression model concerns UW engineering, and the 400 was the data we received. But in order to do a logistic regression model for another program, another set of optimal b-values must be obtained.
So now that Nimesh described the training process for our logistic regression model, I would kind of like to go over the results obtained from our model. So we were able to obtain an overall accuracy of 73%. And over here we have a confusion matrix. So I'm just going to start at 28. So 28 students were false positive, which means the actual value was a no. So the actual value was they were not admitted, but they were predicted as admitted. So they were predicted as yes. 48 students were true positive. So the actual was admitted and the predicted was also admitted. 40 students were true negative. So predicted was a no and actual was also a no. And finally, 4 students were false negative, which means the actual value was a yes, but the predicted value was a no. On the top left, we are also able to see n equals 120. So this 120 is the number of students that were, the number of columns that were used in the testing data. So since we chose a 70-30 split, 30% of 400 students is 120.
Thank you to Radesh for explaining a lot of the data analytics behind the model. Now I'm going to give you a deep dive into the back end of the system and show you all of the calculations. So if I open up the DSS, you will see that there is a sheet hidden that has all of the calculations behind the entire system. So right over here we have the same data that is pasted by the admissions officer in sheet 1, and to the right of the sheet 2 you have the login function. Now as I click into this, you will see that the formula is y equals b0 plus b1 times x1 plus b2 times x2. And these are the optimal b values that we have calculated that Radesh and Nimesh explained earlier. To the right of this, we have e to the l, and this is because it is just the exponential function. And then the probability is p to the x, and that takes all those e to the l values and it puts it in that special formula, the sigmoid function of e to the l over 1 plus e to the l. Now, what the backend system does is it copies these values, these probabilities, these percentages, and it pastes them beside each student row, giving them the probability of acceptance.
So these are some recommendations and next steps to further enhance our DSS. The first one is a database integration to view borderline applications. So all of the admissions data is stored in a database, and admissions officers can look at the students who are near the threshold to get a greater depth inside their student profile.
Another recommendation is to possibly use artificial neural networks instead of logistic regression. The reason being is ANN has the ability to learn hidden relationships in the data without imposing any fixed relationships. With more available data points, ANN could be applied and compared with logistic regression to see which model produces a higher accuracy.
Another recommendation is implementing a system for applicants to understand the application process, basically a decision support for students. A suggestion for this is for the admissions team to be more transparent with their application evaluation process, how each factor is weighted, and possibly providing a sample application and the resulting scores.
The final recommendation would be to create a web app incorporating the Python model. This is because currently the Python model is used to find the optimal b-values, but then it has to be transferred to Excel. So our current system is set up for University of Waterloo engineering admission specifically, but if a university were to use our DSS for other programs, they would need to go into Python and then transfer the b-values to Excel. In order to optimize the whole DSS process, we would like to have all the information in one uniform system. In conclusion, to recap our business problem, there's a lack of standardized application systems for universities in Canada. We were able to realize how our decision support system fills in the gap by looking at the student data and eliminating any external factors or variables. We wish to see our decision support system used by universities in the future to help the whole admission process. Thank you for listening to our presentation, and we hope to see Wadss in the university application future.